Today's video, we are going to discuss 5.6, graphing linear inequalities. So let's begin with these warm-up questions on our worksheet here. We need to graph, we need to remember how to graph, and we need to know how to graph in a slope-intercept form, right? This is y equals mx plus b right here, y equals mx plus b. And how do we graph a slope-intercept form equation? You begin with your b value, -3, and remember that the b value is your y-intercept. This is the y-axis. It crosses the y-axis at -1, 2, -3 right here. Let's put a dot right there. Now, from that point, I know that my line is going to cross right through that point. Maybe like that, maybe like this, maybe flat, maybe really steep going up, maybe really steep going. It all depends on the slope of the line. So in this case, the slope is 1/2, so you do go up 1 over 2 and put a dot right there. And you could continue to go up 1 over 2 to extend it further and put a dot right there. You could even go backwards, over 2, down 1, over 2, down 1, over 2, down 1 to extend it in the other direction if you'd like, right? You don't have to extend it in the other direction. I am going to, so draw your line and you are done. Put some arrows on it, you're good to go. Moving on to number 2. This one crosses the y-axis at 3, 1, 2, 3, right here. Now from this point, my slope is rise 2, run 1. So if you do rise 2 and run 1, you're going to end up here off the graph. Now it exists. The line goes up here off the graph. However, it's going to be difficult to draw it up here off the graph. So, I'll put my point there. We're going to go up 2 over 1. I'm going to put a dot right here. It's off the graph. I'm still going to put the dot there. But my point is, I could use the pattern backwards. Over 1, down 2, over 1, down 2, and put a dot right here. And you could continue to go over 1, down 2, and put a dot right there. And then continue to go over 1, down 2, put a dot right there. So my point is, you could use your slope, the pattern of your slope, to extend the line in both directions. Now obviously you don't have to go off the graph, but there's my graph. So this is just a review of us graphing from before with y equals mx plus b. Now what about number 3? Number 3 is in standard form, and you can't graph in standard form. You could find the x-intercepts, and how could you do that? Well, you could find the x-intercept by setting y equal to 0 and solving. And then you could find the y-intercept by setting x equal to 0 and solving. Or if you wanted to, you could change this to slope-intercept form to get y by itself. It's totally up to you. I'm going to choose to get y by itself. Subtract 3x, subtract 3x. This is why I left some space here. So I'm going to rewrite it. It's -2y equaling -3x plus 6. There you go. Last but not least, I need to get rid of the -2 that's being multiplied in front of the y. So I need to divide by -2 to get rid of the multiplication of -2. And you do the same for all the terms in the equation. So now I really do have my slope-intercept form equation, y equals, now right here you can't really divide 3 by 2, but we do know that a negative divided by a negative is a positive. So it's really a 3 over 2 with an x. And over here, positive 6 divided by -2, that is a -3. So once again, we have our y equals mx plus b, which in this case, the slope is 3 over 2, and the y-intercept is -3. So the y-intercept is -1, 2, 3, put a dot right there. Now from that dot, you are going to rise and run according to your slope. So rise 1, 2, 3, and run 1, 2. So if the fraction is positive, you're rising up. If it's negative, you're going down. But you always run to the right. So again, up 3 over 2. Up 1, 2, 3, always to the right, 2. In this case, 2. Put a dot right there. You could continue to rise 3, 1, 2, 3 over 2 and put a dot right there if you want. You don't have to. But there is my line. Put an arrow, you're good to go. Now this other one, I purposely picked this one because it's interesting. That one's in point slope form. So if you wanted to, you could rewrite this to be in point-slope form, in slope-intercept form. You could rewrite it to be in slope-intercept form. How? By distributing, by moving it over, and then it'll be in y equals mx plus b. Or, knowing point-slope form, y minus y1 equals m parentheses x minus x1, you should be able to identify your point. Okay, now think about that. The value in here is 2, but it needs to be a negative, so what must the y value actually be? It must be a negative 2. That way you'll have the negative 2, which will take you back to the positive 2. So the y value is negative 2. My y value is negative 2. And my x value, if it's plus 1, you really got to think opposite of that, because the x value would have to be a negative 1 in order for the minus to change to plus plus. So the x1 value is negative 1. And of course our slope is the 3 right here. So the slope is 3. So I could graph by going to the coordinate -1, -2, which is right here. Now from this point, I am going to do my slope, rise 3, run 1, because I can make it look like a fraction. So rise 1, 2, 3, run 1, and put a dot right there. And then you could continue to rise 1, 2, 3, run 1, put a dot right there, if you'd like. But here's your line. Now, if you didn't want to graph it this way, how could you have done it? Well, you could have, again, gone back to the original and decided to get the y by itself. So let me do this. Let me just cover up the work that I just did, and let me solve this a different way, or graph this a different way. Distribute 3 times x, that's 3x. 3 times 1, that's 3. Bring down the equal sign, bring down the y, the plus, the 2. It's almost in slope-intercept form. Subtract 2. I will end up with y, because that canceled out, equals 3x, and then 3 minus 2 is positive 1. So there's my slope-intercept form equation, where my slope is 3 over 1 and my b value is 1. So y equals mx plus b. It crosses at 1, put a dot at 1. From that point, rise and run according to your slope. Up 1, 2, 3, over 1, put a dot there. You end up with the same line. And you could use a pattern backwards, over 1, down 3, over 1, down 3, to get to that point right there. So it's the same line. It's totally up to you if you want to change it to slope-intercept, or if you want to actually use the point-slope form to graph. I think most of us would be more comfortable with slope-intercept. Okay, number 4 and 5. Well, we've already done inequalities in the past, and this is just a review. Graph x is greater than 2 on a number line. Well, we are talking about the x-axis. We're talking about the x number line. And let's say the number 0 right here, and then 1, 2, 3, 4, 5. This way, -1, -2, -3, -4, -5. Okay, so if you go to the point 2 and you realize that there's no solid line underneath it, that must mean that this is a open dot, not a solid dot at 2. And what does it say? It says x is greater than 2, and I hope we remember that greater than is to the right. Less than is to the left, greater than is to the right. I hope you guys remember that from previous lessons. This one right here, number 5, it says graph x is less than or equal to 3. Let's just make it a little easier on us. Let's put the 3 right here in the middle, and then fill in some values to the left and to the right. 4, 5, 2, 1. That's already good enough. This one does have a solid line underneath the inequality, so it will be a solid dot at 3. That's what I want to do, solid dot at 3. Again, the difference, this one's open, this one's solid. It's solid because it has a solid line underneath the inequality. And x is less than is to the left, greater than is to the right, so x is less than 3, that is to the left. Okay, so that's a review of all the skills. Oh, a couple more questions, I'm sorry. Number 6, on a horizontal x number line, if you have x is less than a certain value, then the area you're talking about is to the left of that value or to the right of that value. Well, if it says x is less than, that's to the left. If it's greater than, it's to the right. Okay, just the way we demonstrated up here. X is less than or equal to 3, solid dot because of the or equal to, but the less than is to the left. If it would have been a greater than, that would have been to the right. Number 7, on a vertical y number line, if you have y is less than a certain value, then the area you're talking about is above that value or below that value. That's interesting because that brings the next topic, the next section. We're talking about the y number line. Let's say zeros here, 1, 2, and let's say -1, -2, 3. Okay, so if I said y is less than 2, so it'd be an open dot at 2, and less than is not above, it's below. Okay, so remember, greater than is above 3, 4, 5, 6, 7 is above the 2. 1, 0, -1, any negative number is below. So y is less than 2 is y is below 2, less than 2. I hope that makes sense. It's going to lead into the next lesson here. Let's go to the actual notes here. 5.6, graphing linear inequalities. Graphing a linear inequality is the same as graphing a linear equation. It's just like these guys over here, graphing those lines right there. The only difference is that there's a couple of extra steps. And what do those extra steps involve? It involves determining if it's going to be a solid line or a dotted line. And then the other thing it involves is shading where your answers are at. Because when you're solving an inequality or graphing an inequality, you're talking about an area of answers. So the steps are written out for you right here. Let's do step 1. Let's read it and then actually apply it. Rewrite in the inequality in slope-intercept form. So is this inequality in slope-intercept form? Yes, it's y equals mx plus b. I know my b, I know my m, it's ready to graph. It's an inequality instead of an equation. So step 1 is done for us right there. Let's go back to step 2. It says graph it, but determine if it's a solid line or a dotted line. Less than or equal to or greater than or equal to will be a solid line. Less than or just a greater than will be a dotted line. Just like before, if it has a solid line underneath it, then it's a solid. Solid line is going to be a solid. No solid line, it's not going to be a solid line, it's going to be a dotted line. Okay, so let's graph number 1. It's already in slope-intercept form. It crosses the y-axis at my b value of -1. From that b value, I am going to rise -1 and run 4. And when I say rise -1, that means I'm going to drop 1 instead of rising 1. Because it's negative, it's going down 1, and you always run to the right. 1, 2, 3, 4. Put a dot right there. And you could use the pattern of down 1 over 4, but backwards. Over 4, up 1. Over 1, 2, 3, 4, up 1, and put a dot right there. Now, before graphing, before drawing my line with arrows, I need to ask myself the step 2 situation. It says graph it, but determine if it's a solid line or a dotted line. If it has a solid line underneath it, it's going to be a solid line. Do we have a solid line underneath it? Underneath the inequality? No, there's no solid line right here, which means this is not going to be a solid line. So it's going to be a dotted line. So everybody, let's just do like a couple of dashes going through right here. And then draw some arrows. That was step 2. Now step 3 says decide what side of the line to shade. You see, an inequality has a whole area of answers. If I tell you x is less than 5, you're talking about a whole area of answers. It could be 4, 3, 2, 1, 0, -1, -2. You're talking about the whole left side of 5 if I tell you to think about x is less than 5. So right here, we need to decide where the answers are at, so we need to shade in those answers. And how do you do that? You test a point like 0, 0, okay? So if you test the point 0, 0, which is clearly above that red dotted line, if you test the point 0, 0, that means plug a 0 here and a 0 there, it will read 0 is less than -1/4 times 0 minus 1, which is really 0 is less than, that's 0, right? Anything times 0 is 0, minus 1 will be a -1. Is 0 less than -1? Is 0 less than a negative number? No, false. 0 is greater than a negative number. So this is not an answer. Where are your answers at? They must be on the other side of the line. So you would shade in this side down here. All the answers are below this red dotted line. And that's how you shade, by testing a point or testing points. If you pick any coordinate down here and plug in, like let's say I pick the coordinate -1, -3, right? That blue dot right there is -1, -3. If I plug in a -1 right there and a -3 over here, it'll be a true statement. all of these down here are true statements because all of these are solutions. This one didn't work. That means that none of these up here will work. There will be false statements. Okay. Again, when we did plug in 0, 0, we ended up with something false. 0 is not less than -1. Okay, is there an easier way? Yes, there is. You see, if you have y by itself, what is y if you think about that? Y is either up or down. Y is either positive or negatives, right? Y is getting bigger as you go up, getting smaller as you go down. So because of this fact that if you have y by itself, you could actually look at this sign and say or think y is less than. So where is less than? Going up or going down? Y is less than, that'd be less. So your dotted line, it's going to be shaded below because of the less than, only because you have the y by itself. So up here on our step 3, deciding to shade, step 3 is shading, and how do you decide? By testing the point 0, 0. Instead of doing that, it says right here, or if your y is isolated on the left side, you can use the inequality to conclude your shading. A greater than is above, a less than is below. So it's that simple. If you have a greater than symbol, you're going to shade in above. If you have a less than symbol, you're going to shade in below. So let's go through all the process super quick because we've already gone over the steps. Step 1 is to make sure that it's in slope-intercept form, which it is. I could clearly see that it crosses the y-axis at -2, and I could clearly see my slope 4/1. Okay, so let's go to the b value of -2, and let's put a dot right there. Now from that dot, I'm going to rise and run according to my slope, 1, 2, 3, 4/1, put a dot there. And then I need to decide, is this line going to be a solid line or a dotted line? Because there's a solid line underneath the inequality, this will be a solid line. Now, y is by itself, so I need to shade. Step 3 is to shade. So because y is by itself, it says y is greater than. The y-axis is running up and down. Greater than is where? Above or below? Greater than is above. So you're going to shade above. So you could put your pencil on any dot of this line and shade above, then obviously you're going to be shading this side up here. So where are your answers at? They are above that dot. They're above that dot. They're above that part. So this whole thing right here is this is what's shaded. The upper left part of this graph is shaded. Okay? Let's move on and try another. Again, it's all about graphing the line, deciding if it's solid or dotted, and then shading. In order to graph, you need to have it in y = mx plus b form. Okay, so let's first begin subtracting 3x, subtracting 3x. I will have -2y is greater than -3x plus 6. Final step is to divide by -2, divide by -2, divide by -2. Now, on an inequality, I hope you remember from the past, whenever you divide by a negative, you do have to flip that inequality symbol. And a negative divided by a negative is a positive. So we have a positive 3/2. We still have the x there. And the b value, 6 divided by -2, is -3. Now it's in slope-intercept form. Now we are ready to graph. It crosses the y-axis at -3. Now from that point, I'm going to rise 3, run 2, rise 1, 2, 3, run 1, 2, and let's put a dot right there. And you could continue to rise 3, 1, 2, 3/2, put a dot right there if you want to. And then we ask ourselves, is this line solid or dotted? It's not solid because it does not have a solid line underneath it, so it will be dotted. So let's put some dots, some dashes between those dots. And then on top of that, we need to shade where our answers are going to be at. You could test 0, 0, see if it works, but it's easier to recognize that once you have y by itself, you could use this inequality to decide whether you shade above the red dotted line or below the red dotted line. Because it's a less than symbol, you're going to be shading below the red dotted line. So you shade in everything down here below the red dotted line. It's really an easy lesson. It's really an easy section, especially if you're already good at graphing lines. Number 3, it's not ready to graph. Let's get the y by itself, divide by -3, divide by -3, divide by -3, remember that there's an invisible 1 in front of the x. And when you do divide by a negative on an inequality, remember that your inequality has to flip. That inequality is going to become a greater than or equal to. Now the slope is still a positive 1 divided by a negative 3. I'm just going to put the negative sign out here in the front, and I'm going to put the 1 on top and the 3 on the bottom, and there's still an x right there. And the b value, a negative 9 divided by a negative 3, that's a positive 3. So here's my inequality. It's ready to graph now. It's in y equals mx plus b form. It does cross the y-axis at 3. And from that point, I'm going to go down 1 because it's a negative. So down 1 and always going to run to the right. So down 1, run to the right, 1, 2, 3, and let's put a dot right there. And of course, we could use the pattern backwards. Instead of down 1 over 3, go over 3, up 1, over 3, up 1, and put a dot right there. It's totally up to you if you want to extend it in that direction. I would. And then we ask ourselves, is this line going to be solid or is it going to be dotted? It's obviously solid because it does have a solid line underneath it. So draw your line solid, put some arrows on it. And now you need to determine if the answers are below that red solid line or above that red solid line. Because y is by itself, you could use this symbol, this greater than or equal to symbol, to conclude that you shade above. Because the y up here are bigger values of y. Down here are smaller values of y. So greater than, that'd be above. So you shade in everything above that red solid line. Okay? So I hope this lesson makes sense. I hope this video helps you understand how to graph inequalities, which is pretty much the same thing as graphing regular equations. The only difference is before drawing your line, you got to decide if it's solid or dotted. And then after that, if it's a greater than symbol, you shade above. If it's a less than symbol, you shade below. Right? That's simple.